Hello everybody, welcome to booklet 1 of 6, our first booklet, but actually from the calculator paper. So booklets 1, 3 and 5 are calculator, 2, 4 and 6 predominantly non-calculator. However, as we go along there are little bits that are on both lists, and in booklet 5 and booklet 6 you will get a full revision list for each paper where you can see exactly what you need to revise. So this booklet is predominantly paper 2. The only one that could come up on paper 1, or we are told might come up on paper 1, is Pythagoras and trigonometry. Okay, which is going to be, according to our list, on P1 and P2. All our examples in this booklet we will assume to be paper 2 with calculator, and then as we prepare ourselves nearer the time for paper 1, we'll have a look at how they could manipulate the numbers to make them easier without a calculator. But everything else, paper 2. Let's get into it. And we start with trial and improvement, an intermediate topic, okay? So putting numbers in, checking if the answer is too big, too small, etc., etc. It says here, remember to set up a table format. And this bit also important, remember once you have a guess too big and a guess too small, to end with a check guess between the values. For example, if 2.3 was too small and 2.4 was too big, then we would try 2.35 purely as a check, not as an answer, as a check. And if this check were too big, the answer would be 2.3. And if the check were too small, the answer would be 2.4. Now in the first one, we've got it equal to 20. So we're going to put numbers in for x there and there and try and get the answer close to 20. But we won't do that one, we'll do this one. Okay. Again, be careful with this one, all right? The only thing I'm going to say on this one is, I guess what the table I'm looking for is the first column is something like guess, or a try, whatever it is we're going to guess or try. The second column then is our method or workings out. And our third column is where we say if our answer is too big or too small. You will get used to this pen being a bit delayed writing. It's not the best, but we're going to do our best with it, okay? And if I need to, I'll explain what I'm saying just in case you can't read it, okay? So in this one, it's an unusual one because it's telling me what it lies between to 1 decimal place and asking for a solution to 2 decimal places. Highly unusual. So my first guess is halfway between 7.2 and 7.3, which is 7.25. I'll do the method, etc., which we'll come on to later. If it's too big, we'll make our guess smaller, something like 7.24 or 7.23. And if it's too small, if this guess is too small, we'll make our answer bigger, something like 7.26, etc. Once we've got one of these to be too small and another one next to it too big, so we know what the answer's between, then our check will be 7.2, depending what the answer is, 235 or 245 or something in the middle, okay? If that doesn't make sense, you need to see a proper method worked all the way through. So let's find one, possibly the most difficult one here because of that 2 there. Okay? Most don't have that. And we're looking for the answer 0. Anything above 0 is too big. Anything below 0 is too small. And in this, luckily for us, it won't say like use an algebraic method or anything like that. It will literally say use the method of trial and improvement. No, meaning if you don't use this method, you ain't getting the marks. Okay, so my first try or guess, or whatever you want to put that, is going to be x equals halfway between this and this, so 1.5. Now, into the calculator. Every time I see x, I put 1.5 in brackets. So 2 in brackets, 1.5, close brackets, cubed, plus, again, this doesn't need to be in brackets, but I just get used to it. Every time you see x, putting it in brackets, minus 10 equals, and we don't put equals 0, we don't know, okay? Now, you're going to have the boring bit here of me having to do this on my calculator, which is what I'm doing at the moment. Maybe while I'm doing this, you can just check, putting it into your calculator just to check you get the same answer as me, okay? And my answer for this is minus 1.75. which is below 0, which is what I was aiming for. So it is too small, and you must write that. So every line needs to look like that for proper workings out, okay? Because it's too small, we're going to try something a bit bigger. I'm going to take a bit of a jump up to 1.7. I'm going to miss out 1.6. I'll come back to it if I need to. Again, look at the way I write this out. Every number in brackets. And again, we put this into our calculator. You have a go at the same time as me. Get your calculator now. And I get for this one, interesting. I mean, again, I'm assuming I'm right. Yeah, okay. 1.526, which is too big. It's above 0. So now I do need to go back down to 1.6 and check that. Again, I'm not going to write this one out in full, guys, just to save a bit of time. I'm just going to put it into my calculator. 2 times 1.6. You can't get away with this in the exam, obviously. You need to write all your workings out. And that I get to be minus 0.208, which is too small. Okay. My answer is bigger than this and less than this. It's between these two numbers. So my final thing is to write, I am now doing not an answer, but a check. And my check is halfway between 1.6 and 1.7, which is 1.65. I just put a 5 on the end of the smaller one. Again, I write it out in full. A lot of this video is you just waiting for me to write things out, right? But you could be doing these in your calculator just to check your calculator usage is good. Okay, so 2 in brackets, 1.65, close brackets, cubed, plus, open brackets, 1.65, close brackets, take away 10, is 0.63, and I'm giving as many decimal points, you know, I'm going to give 4 or 5. If you just write them all, what do you see in your calculator? Write it all if you need to, okay? Which is bigger than 0, so it's too big. Now, be careful how you end this question. Because the check is too big, the answer is smaller than that, so my final answer is that, because it's lower than 1.65. So X, and do actually write that, circle it, do something to it, okay? That is my final answer. You can try the rest of those. Okay, the next bit, finding original amounts, intermediate. Now, okay, what we sometimes call reverse percentages, right? But we've got a calculator, so I'd like you to follow this method, which might be different to what we've done before, but this is the method we're going to use, okay? Right. I don't want you to worry about this too much. I put this in to show you how you can do a percentage on a calculator, but this is reverse. This is going backwards, finding original amounts of this. Like it says, however, this question will ask you how to reverse that change. So, to find the original after a number has increased by 3%, you've got to think, in order to increase a number by 3%, I would times by 1.03, which is the original amount, add the 3% on top. But to reverse that, I need to take the answer n and divide it by 1.03. Or the second line, to find the original after a number has been decreased by 3%, well, to decrease a number by 3%, I would times it, not by 1, but by 3% less than 1, which is 0.97. But to reverse it, I divide by 0.97. To give you an idea, now some of these are wrong. I'm really sorry because they're identical there. All of these, bottom 3, should have said decreased. Okay? So you've got 3 increases and 3 decreases. So if a number is increased by 6%, how would you find the original number? You would divide that number by 1.06. If it was 60%, you would divide that number by 1.60, or just 1.6, the difference between 6% and 60%. However, I miss out number 3 and do number 4. If the number has been decreased by 6%, in order to decrease the number by 6%, you would have times by 0.94, And the opposite of that is to divide by 0.94. And notice all these questions are about dividing, okay? Or to find the original number if something's been decreased by 60%, sorry, we're going to divide by 0.4, okay? You fill in the missing 2. Okay. This is a poppy. I don't want you to, because this isn't going backwards, this is going forwards, okay? And every time we go forwards, we're increasing by 20%. So we're times in by 1.2 and times in by 1.2. And he wants to know what would be on diagram 6. So you just continue increasing, but use the calculator technique, which is times it by 1.2 rather than finding 10% and doubling it. You would get it right, but it's just much quicker to do it this way and can just continue. That's for D4, and then D5, and then D6. I'm not going to say any more about that. Okay, they could actually say, rather than what's the calculation, they might make you work out the original. So when a number is reduced by 15%, okay, in other words, it's been times by 0.85 to reduce it by 15%. The answer is this, and there's your clue. What is the original? What is the original? That means divide. If I want the original, I divide. Okay, so I'm doing 6154 divided by, reversing the calculation, 0.85. And I'll give you the answer to that one. Is 7 to 40. Now, I've mentioned these notes here. If you did a repeated increase or a repeated decrease and you were reversing it, okay, then you put what's called a multiplier on it, okay? So if I wanted to decrease a number by 12%, I would times by 0.88. Remember, if I was finding the original, if I was going backwards from the answer, I'd be dividing by that, but okay. This is done 3 times, each time decreasing. In other words, okay, that's what I'm looking for. All right, and then it asks you a few questions about that. Now, this last one. After increasing a number by 2% 3 times, the answer is this, and there's that word again. Go back to the original, divide. The times bit has been done, reverse it. Take that number there and reverse what happened there by dividing by 1.02 to the power 3. And the next section, upper and lower bounds. Okay, look out for phrases such as degree of accuracy or to the nearest or correct to highlight an upper or lower bounds question. Okay, so if it says this number is to the nearest 10 or this number has a degree of accuracy of the nearest whole number or whatever, those sort of words, okay, then you pick out, hang on a minute, this must be upper and lower bounds because that number is not correct, it's to the nearest something. Okay, to find the upper and lower bound, which you must do for every number that has a degree of accuracy, half the error, add it on and take it away. And then if we have to do a calculation, adding and multiplying, upper bounds give you bigger answers, greatest values, and lower bounds give you lower answers. If we're dividing and subtracting, we're going to need one of each, and that's a little bit more tricky. Okay, now, this is to the nearest whole number, the degree of accuracy. So half of a whole number is 0.5. So I'd be writing down here, my upper bound for the first value is 64 and add on the 0.5. And my lower bound is 63.5. Listen very carefully to the following statement. What you do not do is work out the sum and give the upper and lower bound of the answer. You don't do that, you find the upper and lower bounds of the numbers in the question and you use those to get the answer. Okay, so I do not want to see D, 64 going in there and 8.6 going in there, and then I get an answer and then I do some upper and lower bounds work. No, I get the upper and lower bounds of this number, I get the upper and lower bounds of this number, then I put them in the sum. So for the second number, to the nearest 1 decimal place, which is 0.1, decimal place. Half of that being 0.0, pen starting to go, 5. So I get an upper bound of 8.65 and a lower bound of 8.55. Okay, scroll down a little bit. I want the least possible value of this division, so think about it. I need to square D. If I want to keep this low, I want the lowest number. So I'm going to use 63.5 squared divided by E, which is this number. But if I want to keep my answer low, I've got to think to myself, do I want to divide by the lowest amount or divide by the biggest amount? And actually, to get the least answer here, it's the lower bound of the top, but we would divide by the upper bound at the bottom. So we're divided by 8.65. Into your calculator, guys. Check that you've got the same answer as me. And because this is our final answer, it's a long recurring kind of, no, it's not even recurring. It looks like the number goes on, it's got quite a few decimal places. Okay, you need to give an appropriate degree of accuracy for your final answer, which I would suggest to be 1 or 2 decimal places. So if you're giving 1 decimal place, it would be 466.2. If you give 2 decimal places, it would be 466.16 if you round correctly. Check that on your answer and be happy with rounding. Okay, fab. What else we got? Okay, this talks about significant figures. Correct too. There's your kind of hint that it's upper and lower bound, and this would least, all these kind of clues, right? All I'm doing is T divided by W. If I want the least, I want the lower bound on top again and dividing by the upper bound. So my lower bound of that, correct to the second significant figure, means correct to that, the second digit there. Because that's in the units column, half of a unit is 0.5. All right, so we'd add that on, take that away. And here, the first significant figure here is the 5 there, which is in the tenths column, right? And half of a tenth is 0.05. So we would add that on and take it away. So this sum I'd be doing 97.5, the lower bound of 98, divided by the upper bound of the bottom number, which is 0.55. And it actually says, read these questions. Read it, underline, pick out the important bits. Right, if I'm going to drop a mark here, if I don't give my answer to 1 decimal place, or if I don't show my working. Okay? You do that. Easy enough. Yeah. Nearest centimetre, so 24.5, 23.5, list them. 15.5, 14.5, list them. Give those upper and lower bounds before you even start. Lots of marks for that. And then the greatest possible perimeter, well, we know perimeter is adding up all the way around the rectangle. And the least possible perimeter, again, adding up all the way around the triangle. Okay, so the biggest perimeter will be adding up the upper bounds all the way around, and the lowest perimeter, or the least perimeter, adding up the lower bounds all the way around. Don't like this, yuckaby. An amount written correct to the nearest £10 is that. Okay, let me get a mark in the bag. Nearest £10, I know what half of £10 is, it's £5. So my upper bound is 718. Add on that fiver. And my lower bound, my pen is really starting to play up here, is 71 and take away the fiver. Correct. This amount is increased by 23.5% correct to the nearest 0.1. Half of 0.1, 0.05. Added on, 23.55%. Take it away, 23.45%. Again, label them as upper and lower bounds. Okay. Plenty of marks for just doing that. I haven't even read the question, just picked out the numbers, given the upper and lower bounds of them all. Least possible value of the increased amount. Okay. Oh, that's not very nice, is that? Okay. So, in order to increase this by 23.5%, okay. Not very nice at all. But to get the lowest answer, you would multiply, wouldn't you? It's the number times the increase. So what you want is the biggest percentage on the biggest number will give you the highest answer here, or putting the lowest percentage on the lowest number will give you the lowest answer. Now, there are other ways to do this. You could work out that percent of that and add it on. And the way I'm going to do it is I'm going to use multipliers like we did in the last section. I'm going to times by 1 point. And if it were 23%, it would be 23. But 23.45% is that. Like I said, alternatively, do what you do. Okay, but that will give you the right answer here. And give your answer to the nearest pound. Times 1.2345. It's horrible. But to the nearest pounds, it's 885. And my calculator says 7 then 0.5. But because it's 0.5, that will round up to 8858 to the nearest pound. Read the question. Don't drop a mark for doing all that work and not doing that. Okay? Speed is distance divided by time. In that triangle. Okay? If I want the least possible speed, then I want the lower bound of the distance and the upper bound of the time, because I am dividing and I want my answer to 2 decimal places. In terms of the distance, it's the nearest 5k, so we will add and take away 2.5, which is half of that. And this is to the nearest hour, so for our upper and lower bounds here, we will add and take away half an hour, or 0.5 hours. You have a go at that. The next section is similar shapes higher. What that means to you guys, the fact it's a higher tier, means it's not on the intermediate paper. It kind of narrows down what they're going to ask. An intermediate question would only involve length scale factors. Here's a length here, here's a length here, here's a length here, what's the length here, that kind of thing, okay? And by length, there are lots of words depending on the shape for length. A radius is a length, a perimeter is a length, a circumference is a length, a diagonal on a square is a length. Do you know what I mean? There are lots and lots and lots of different lengths. Also, if we're talking about area, it might say the area, it might say the surface area. They're all areas, okay? And volume, the same thing. So be careful what it is that they're actually telling you. Now, let's write some notes in here. The big note that I've got to say is there are 3 scale factors. A length, area, and volume scale factor. Depending which one I know, okay, depends what I do. If I know this one, then I will need to square it to get that one, or cube it to get that one. So if I know the length scale factor, but I want the area scale factor, I square it. If I know the length scale factor, but I want the volume scale factor, I cube it. Or if it's one of these that I've been able to work out, but I want this one, then obviously I do the opposite. I square root this one to get that. Or I cube root, which looks like this. It looks like a square root with a little 3 there. I cube root that one to get that. So the first question I'm going to ask you in these questions is, which one have I worked out? Which one do I need? Okay, that's what we're going to approach these. Which one have I worked out? Which one do I need? And we'll get the one we need by doing whatever it is we need to do here. Okay. The second question you're going to ask yourself is, once I've got the one I need, am I going to times by it, because I know the thing on the smaller shape but want it on the bigger shape? Okay, so smaller shape here, for example, bigger shape here. Am I timesing by my scale factor, or do I know what I want on the bigger shape and need it on the smaller shape, in which case I am dividing? Get those 2 in your head. This is an easy higher tier question. Okay, should be easy for you guys. Now, I've started with an intermediate example. I'm not going to say too much about it. You've got calculators. So I don't even need to go into how to do this without a calculator, okay, which is a lovely, lovely, lovely news. Pick a pair of sides I know, this one and this one. It's the only pair that I know, right? Or equivalent side that I know, that one and that one. Here I know the 3.2, but I don't know x. And here I know the y. Sorry, I don't know the y, but I know the 6.3. If I divide 8.4 by 5.6, I am dividing lengths, so I will get a length scale factor. In order to work out what x is, because it is on the bigger shape, I will times 3.2 by my length scale factor, or to get y, which is on the smaller shape, I will take 6.3 and I will divide by my length scale factor. But this is an intermediate question. It is all to do with lengths. No area, no volume, just the lengths of the sides. So I do not think that this is the standard that we need here. Okay? I think we need to up it to these questions. Okay. Two similar cones have volumes of this and this. By dividing those numbers, bigger, always bigger divided by smaller, I asked you to ask yourself the question, what is it I can work out? Well, dividing by those numbers, which the answer is 64 on my calculator, I have worked out the volume scale factor. So that is the one I have worked out. Let's go back to the picture up here. That is the one I've worked out, the volume scale factor. I have divided volumes. Now, which one do I need? The radius. Now, the radius is a length. The radius of the base of the smaller cone is 2.3. What is the radius of the base of the larger cone? So what I need is the length scale factor. In other words, I have to not square root, but cube root 64. Again, you can use your calculator to do that, and it's 4. So, question 1, what have I worked out? The volume scale factor. Question 2, what do I need? The length scale factor. Worked it out. Question 3, am I timesing by 4 or dividing by 4? It says the 2.3 is the smaller length, therefore on the bigger shape I will have to times by 4 to get the larger length. Okay? Computer's on my lap here and seems to be heating up a lot. Anyway, let's crack on. Hope it doesn't just die on me. Here we go. I'm sure we'll be okay. Two similar solids are shown below. Okay, I can already see that is a length. That is a length. These shapes could have we could talk about area, we could talk about volume because they're 3D shapes, but the numbers that I'm seeing in front of me are lengths. And in fact, they are heights. Okay? So by dividing those, again, you should do this down in the answer area, not here. And using your calculator, okay, you get in the length scale factor. However, what I want is, well, let's read what I want. Mary claims that the surface area of solid B is more than double the surface area of solid A. So we're not actually working out the area of solid B. It's just Mary saying she thinks the area of this one, the surface area, is more than twice the size. A lot of people are going to go, no, she's wrong because the scale factor is 1.4. But that's the length scale factor. This question part is asking about areas. So to get my area scale factor, I'm going to take the length scale factor and square it. Now, without the calculator, you would do maybe 14 times 14 and put in 2 decimal places. But we've got a calculator, so it's 196, but with 2 decimal places, it's 1.96. So basically, the area of this shape is 1.96 times bigger than the smaller shape. But Maria said the area of solid B, or the surface area, is more than double. Well, 1.96 is less than double. And the question, we always answer the question. What does the question say? The question here is Mary correct? Well, nothing I've written there says if Mary's correct or not. So we can put now, Mary not, or is incorrect, or not correct. Always answer the question. Read it. What is it they want you to know? Okay. Let's have a look at the next one. Two similar shapes have areas of these and these. So we'll start by working out the area scale factor. big divided by small. The perimeter of the smaller shape is 83, so the one that I want is the length scale factor, because perimeter is a length, and I am told that the smaller one is 83, so once I work out my length scale factor, I'll times by it to get the perimeter of the bigger shape. A rhombus is an area of this. The rhombus is enlarged by a scale factor of 7. When it says a scale factor, guys, invariably, if there's no word before it, it means length. Okay? We tend to just say scale factor instead of length scale factor, whereas area scale factor and volume, we say those words. So the length scale factor, we haven't even had to work it out in this question, is 7. And we're talking about the area, so we need the area scale factor, which is 7 squared, which is 49. And we will times that by 49 to get the bigger area. Sorry, the area of the bigger rhombus, I should say. Right, I just want to mention this one because it's ridiculous. Absolutely ridiculous, right? Because in this one, area of the base, area of the base, area scale factor, okay, work that out. Don't round it to any, give quite a few because it's not the final answer, all right? However, I want the volume. Absolutely ridiculous. The only way to get from area to volume is to go via length. You can't go direct. You'd have to go, well, let me start by getting the length scale factor, which is the square root of the area scale factor. Let me start by doing that. Once I know the length scale factor, actually what I want is the volume scale factor. And to get that, whatever my length scale factor answer is, I'm going to cube it. So let me show you on the original diagram. So almost like we're going full loop. We're going from here, back to here, all the way around to here. So square root it, and then cube it. Okay, and that, I'll leave you finish that question off, I think. Unless there's anything difficult. I'll calculate the volume of the larger solid. Well, you're told the volume of the smaller solid. You know your volume scale factor. You can times by it to get the larger volume. And the last one, volume and volume. Work out your volume scale factor. Height of the larger pyramid is 25, so you need, work that out, use it to get that. And because this is the larger pyramid and I want the smaller pyramid, we're going to do 25 divided by your length scale factor. Quite a nice question, I think, for a higher tier topic. Simultaneous equations, beautiful. Here we go. In this one, guys, the main thing here is the notes of this, and they make y's equal, and then same sign subtract or different signs add, and then find x, and then the bit some people miss out sometimes, this bit, substitute x to find y. Let's just go through that, okay? All right, now notice, okay, what it says here. All right, look at the wording. Some say simultaneous equations, okay? It might just say use an algebraic method, but you're looking, if you see that setup, right, that should be a giveaway. Hang on a minute. 2 equations, both with x and y in them, simultaneous equations, okay? Just picking ones that we can have a look at, ladies and gentlemen. I think it's quite a nasty one at the end, and then I'll talk about some of these words. Yeah, this one maybe not so nice, okay? Because I don't like the fact that they're both negatives, both minuses on the y, so they are the same signs. So we will subtract, okay? But we're going to make them the same first. We'll make them both 6. Remember, if you want to make that 6, everything on that line gets doubled. And here, to make that 6, everything gets tripled. So we've got 8x minus 6y equals 22, if I double all that. And on the bottom, we've got 18x minus 6y equals 27. Now, the reason I went for this one, ladies and gentlemen, is adding it doesn't matter if you do top add bottom, bottom add, it doesn't matter. You're just adding the two things together if it was different signs add. But when you're subtracting two equations, it's always better to take smaller numbers away from bigger numbers if the equations allow you. So here you can see that the numbers on the bottom equation are bigger than the numbers on the top. So what I'm actually going to do here is I'm going to do bottom, take away top, because it just leaves me with nice positive answers. So 18x take away 8x is 10x. They get eliminated by taking them away. That's the whole point. Okay. Now, again, another mistake I've seen a lot of times in questions like this. X equals 2. 10 divided by 5. No, it doesn't. At all. That 10 is times in that x. We have to divide by 10. And if you put that in your calculator, it's not 2, it's 0.5. Just keep checking. Go back, check over things. Have I divided by the right number? Or have I done what I think makes it easier? Right? Okay. A lot of people stop there. This is what I'm saying. So we've done part 1, which is making them the same. Part 2, which is same sign subtract. Part 3, which is finding x. Part 4. Copy one of the top equations. Let's go with the top one. But we now know that x is 0.5. So instead of x, we can substitute in there. And again, I always use brackets for substituting. 4 0.5s and your calculator is 2. Now, options. You could move the 2 over that side, but you're leaving yourself with minus 3y. If we did that, it would be 11 take away 2, which is 9. But instead of dividing by 3, we're dividing that 9 by minus 3. So the answer is minus 3. Option 2 at this point would be to leave the 2 this side, the 4 times the 0.5, bring the positive 11 over that side, and actually take the minus 3y over as a positive. The answer is minus 9 equals 3y, and we're dividing by 3. But again, the answer is minus 3. Okay, either of those. As long as the answer is minus 3, it doesn't matter, does it? Okay, before we just do Pythagorean trig, let's just be careful of a wordy thing. Generally 2 shapes, guys, I'd say, right? Or 2 things to compare. 7 adults and 2 children cost this. 4 adults and 3 children cost this. You're away. 7 adults, call them A and B, or A and C if you want. I'll use X and Y. 7 adults and 2 children, and the cost for the Morgans is $41.50. Whereas the Smith family, there are only 4 adults and 3 children, and the cost is $29.75. Have a look at that question and go, if I read that, would I recognise that there are 2 equations I can write here for 2 different families? Therefore, this is simultaneous equations, 2 equations, simultaneous equations, okay? Because it doesn't say simultaneous equations, it says solve your equations. There's a bit of a clue, I suppose, that there's more than one equation. Anyway, and you try and find x, and why have I used c? Either use a and c, or x and y. I've used a bit of a mishmash there, haven't I? But there we go. Doesn't matter. Or something with a couple of shapes. Each side of the square is that, and the perimeter is 62. So if I times that by 4, because there are 4 of them added together, so I get 8x plus 12y, and the perimeter is 62. Or here, there's 8 of those sides, so if I expand the brackets, I get 8x plus 16y equals, there's an octagon, equals 72. Okay, you got calculators. Again, I know the x's are the same and you can do it like that, but listen, if you follow my method, I always say make the y's the same. All right, a little bit harder. Trying to think of like what they both go into and stuff would take a little while, right? But if you did your 12 times table, 12, 24, that's not in the 16 times table. 36, neither is that. 48, that is. Okay, so this one we're going to times by 4 to make the y's 48, and this one we're going to times by 3 using your calculators to make the y's 48. Then same signs subtract. Be neat. Okay, beneath OCW. At the end, for example, if you have to find the value of x and y, what are we talking about? What are they? Well, x and y are lengths. So I want x equals something centimeters, y equals something centimeters. I need a bullet point. What's my first bullet point? My first bullet point is I'm going to make the y values equal. Then I'll write rather than SSS, same signs, so subtract. Bullet point, what am I doing? Right, bullet points, just to get these extra 2 marks, which are here. We need bullet points, and we need units to be correct. If we're talking about centimeters, we keep writing centimeters, for example, okay? And finally, Pythagorean trig. Not a lot to say. Let's start with Pythag. If I know that this is 14, and I know that this is 15, and I want to know this, then I know 2 sides of a right angle triangle, and I want the 3rd side. That is Pythag. Even if it crops up somewhere else, if I've got a right angle triangle, I know 2 sides, I want the 3rd is Pythag. I use square, square, add, and whatever that answer is, square root it. Alternatively, if the 15 is there, the 14 is there, and I want x there, because x is a smaller side, not the big side, I square, square, and I subtract those before I square root. And that's what this means here, okay? Square, square, add square root to find the big side of hypotenuse. Square, square, subtract square root to find a little side. But you need to know the other 2 sides in order to use Pythag, okay? Trig. I'm not going to do examples there. Right, let's have a look at this. Calculate the length of QR. Have a think. QR is the big side. Square, square, add square root. Next. Bit of trig. We don't know 2 sides here. We know a side and an angle. Let's label them. The big side is the hypotenuse. If this is the angle I know, the angle is like an eyeball looking over here at the opposite. The other side is the adjacent. So, car, tower. Well, you'd have to recognise first of all, right angle triangle. I know an angle. I know a side. Trig. I know an angle. I just said. Cross out SET. I know the hypotenuse. 13.8. The other 2 sides, don't know them. Which one do I cross out? Depends. Read the question. Calculate the length of the side AB. This is this one. This is the one I want. AB, this one here. Super important. Let's cross out A. Why have I not crossed out O? Don't know it. Don't care what it is. So the triangle I'm using, go through all this method, please. Start with the C, then the A, then the H. Get them the right way round. In order to find the adjacent, it is C, which stands for cos of the angle, close the bracket, times H, which stands for hypotenuse, which is 13.8, into your calculator. Cos 41 times 13.8. And again, think about it, this is the final answer, so I think here an appropriate degree would probably be 1 decimal place, which is 10.4 centimeters. Okay. Dodgy, right? Mixed into these questions, you might get questions about the area of the triangle. We're still in intermediate here, we haven't, right? And so think, if you were an intermediate person, you wouldn't know that half AB sine C. You wouldn't have ever heard of it before in your life. So the only way you know is base times height divided by 2, or I actually prefer half base times height. Half the base times the height, okay? So to get the area of this, it would be half the base times the height. There's the area, okay? What is it asking me for, though? It wants the perimeter, okay? In other words, I need to know this, this, and this, right? Well, I only know one of those so far, so why have they told me the area? Well, I assume they told me the area because I need to work out what the height is, okay? So, if I half the base, if I half 24, I get 12. What do I have to times that by to get 84? Well, 84 divided by 12 means the height is 7. Again, still not enough info for the perimeter. I still need to know this side to add them all together for the perimeter, but I now know two sides of a right angle triangle, so I can use square, square, add square root to get the final side, and then add them all together to get the perimeter. Again, SoCal Toa, guys, because we know an angle and we know a side, have a practice. Interesting. First one that I think is dodgy. It looks like Pythag. Side, side, beautiful. And I can work out that side there. Square, square, subtract square root. Until I read the question, which says calculate the size of Q, P, with a roof on P, R. Calculate the size of that angle. So actually it doesn't want the other side. It's not Pythag, it's trig. But this is the important angle for the trig. So SoCal Toa. Getting that, guys, isn't we? Right, this time I cross at SCT because I want to know the angle. This is the opposite of that angle, O. This is the hypotenuse, H. And A, the adjacent, the final side, I don't know and I don't care about. So I'm going to use so. Get these the right way around again. And I'm using so to find the angle. So S, which stands for sin, angle, but I don't know it, so I could call it X, I could call it P, I could call it, well, the one I tend to use is theta, equals O, which is 9.6, divided by 16.7. If you choose to put this into your calculator here, because this is not the final answer, you don't want to be rounding this to a lot of numbers, okay? So if you choose to do this here, which you can, you're going to need at least 3. I'm going for 4 decimal places because my final answer is theta equals, and with if you're finding an angle with trig, you've got to take the sin or the cos or the tan over and use the inverse. Okay, so you press the shift button, sin, put that decimal number there in and press equals, and it's around to 1, now you can round this because this is your final answer, 35.1 degrees, and depending on the accuracy you've used here, that might be out by a decimal place, so go with your answer. Trig, is it possible to draw a right angle triangle? Well, again, not the best question, right? Because in other words, but what you want to do is basically, if it's a right angle triangle, then Pythag tells us, well, first of all, call that X, right? Square, square, add square root. If the answer is 25.6, rounded to 1 decimal place, then this is a right angle triangle. If the answer is not 25.6, then this is not a right angle triangle, okay? Because for it to be a right angle triangle, basically a squared plus b squared would have to equal the hypotenuse, the big side squared. So if those squares do not add up to that, then it's not. But you could do it, like I said, you could use your trig and check if the answer is 25.6 once you square root it and just say yes or no. Then you could get these dodgy ones, right? Look at this, we want X, but we only know one thing about this triangle. So start with this triangle, use the angle and the side to work out the hypotenuse using the opposite, okay? Which will be so. Opposite and hypotenuse are important there. Once you work out the hypotenuse, in this triangle, this is the opposite, this is the hypotenuse, and actually on this triangle, this becomes the adjacent rather than the hypotenuse. So on triangle 2, we will now know the adjacent and we will know the opposite, and we are trying to work out the angle. So that's nice practice of both types of trigonometry. Trigonometry to find a side and trig to find an angle. Have a go. The perimeter of a square is this. Calculate the length of the diagonal. You wouldn't spot this was one of these questions, would you? Potentially not, until you did that and you thought, well, what is a diagonal of a square? It's that, and I want to know it. Okay, maybe now you might click, oh, hang on a minute. If I draw, that's a right angle triangle. But I need to know x, I'd need to know how long this is, and I need to know how long this is, right? Then I could do square, square, add square root. You know, square, square, add square root to get the length of the diagonal. But without knowing them, having said that, if the perimeter is that, each side is that divided by 4, and then you know the sides and you know where to go. Another one, ladies and gentlemen, on the first triangle, side and a side, and we will have to work out x, that's trigonometry to find an angle. And then on the second shape, well, if this is 90, if we know what x is, this bit is 90 take away x, okay? Once we know that angle in there, and we know this side, we can then do part B, which asks us for the length of AQ, which is the hypotenuse of this, using 7.9, which is opposite the angle there. And I think you need to have a go at some of these. Maybe have a little look at those, check you're happy, come to me if you're not. Okay, there's plenty of examples. Another one there, look, involving knowing the area where you've got the base. And then this would be the height. It's almost like they've rotated that triangle there. Well, to get the height, half the base, which is 2.5, times what would make 35? Well, do 35 divided by 2.5 to get the height, and then you can do the second part. Right, that's the end of that booklet. Come to me with any problems on that.